Well, hello friends. Welcome back to browser hacking. Today we're going to start on a little bit of path stuff for the canvas element. So far we've only been doing draw image and fill rect, and we also have stroke rect. But today we're going to add the path stuff, and we're not going to do all the different types of path components, but I figured we could do lines and movements at least, and then of course, you know, begin path, clear path, and stroke path, stuff like that. So we'll just start by making a little test because I have not used these functions in forever. So let's see, canvas path. This will be a very, very basic test to begin with, just to refamiliarize myself here. We should have some kind of a boilerplate canvas page almost. Canvas and script. Okay, and let's make sure we set it up with some nice size to begin with. Okay, so what do we want to do? Var context is document, query selector, canvas, 0. All right, get context. Okay, and then we want to begin path. And I guess we want to, let's fill it up with something first. So like, fill style is black. All right. And then maybe we can do this to make it a little bit nicer to edit. So what do we want to do? Like, I have to remember how this works. Move to 20 by 20, 2020, and then line to 80, 80, move, I don't know, let's just do something goofy. 50, 30, context, line to 10, 40, whatever. Stroke style is red, and context stroke path. I just put numbers in now. I have no idea what it's going to look like because I don't have this kind of brain where I can write something out like that and know what it will look like. But I guess I should have predicted that it would look like nothing because it has some problem. Query selector did not work out. I guess because I only needed query selector, not query selector all. And then it's not called stroke path, it's called, I don't remember what it's called. So we'll go look it up on MDN. Maybe it's just stroke, actually. Stroke, yeah, it's just stroke. All right, so yeah, begin path, move to line 2, close path, stroke. Hey, in fact, we could also just take their example here, but maybe we don't take it right now. Stroke path was supposed to be stroke, and we had to also do a close path. Alright, so look at that path. Isn't that just something? Maybe we'll use their little test instead. It definitely sounds a bit nicer. So what was that? We needed a stroke style. Context stroke style is red. Okay. And I guess the fill style should really be different after we filled it with black. So we'll do white. And there we are. Okay. That's a pretty cute one. Way better than my goofy stuff. Oh yeah, and here's how it should look like. But I like the colorized version better, so let's use that. Okay, so let's make this work in our canvas. We have, I mean, we can bring this up and see how long we get, actually. So let's go and make this the default page of the browser, just for simplicity. And then we'll just kick it up and see what happens. Nothing happened. Type error. Undefined is not a function. All right, so this is so annoying. Like, I wish that we would know something more about this. So I'm just going to go ahead and take a quick detour and add backtraces to exceptions. So really, we're just going to like print a backtrace. And we'll use the console object trace logic that Linus added. So basically just walk the call stack backwards. And we don't have to skip over the console.trace frame here, so we go backwards like that, and function name is a fly string, so we can just say, wait, fly string doesn't have is empty? Oh, we should just add that. Fly string full is empty const impl or impl is or if the impl length is 0. Okay. Boom. And then we want to send it to the debugger instead of the standard out. Okay. So I think that should give us backtraces when we throw exceptions, which will be extremely useful. And I don't know why I didn't do this earlier, probably because I was not debugging JavaScript really, but since we can do it, let's just do it. Let's see what this looks like. I mean, the backtrace is not going to be terribly interesting because we're in the global execution context. So yeah, you can see here we're throwing a JavaScript error type error in the global execution context. But still, it's interesting if we add a function here, like function draw, will this be Webby, draw house in web case. And then we do that, and then we say draw who's a. And then we should see draw house in the call stack. Let's just verify that. Yes, look at that. A backtrace. How cool. So let's commit that. Hack add flag string is empty. That was just an oversight that we didn't have that. And then interpreter JS dump a backtrace JavaScript backtrace when throwing exceptions. When throwing exceptions, yeah. And then this one we'll ignore. So I guess line width, we don't have line width, but it will just set it as a property. So this one will just kind of be ignored. And I think we can ignore it for now too. We have stroke rect, we have fill rect, but we don't have begin path. So let's go to the canvas wrapper and then add all of these functions. So put native function begin path, and then we had close path, and we had stroke. And we had move to and line to. Okay. So what these functions do is that begin path clears the slate. You start with a new drawing path, and then move to moves this sort of the invisible cursor to a coordinate, and then line to draws a line from wherever the cursor is to a new place. And move to and line to, they both take an XY coordinate, but move to is kind of like it doesn't draw anything, whereas if you do line to, then it draws from the cursor to the new location, but both of them move to a new location. That's the basic idea. So yeah, I think we can start with these, and actually maybe we should have a setter for the line width. Yeah, let's do the line width thingy as well. So that will be a line width getter and line width setter. And those are native properties. So line width getter and line width setter. And then we should also declare all of these things. Ploop, ploopity ploop. Okay, doing some hardcore text editing here. And it just takes one of these. Alright, we're almost there. Okay, great. So, how do we implement all of these things? The line width thingy is pretty straightforward because we are just gonna forward to the C++ object. Which will have a line width function that returns an integer, or actually maybe a double or a float. Maybe a float, I don't know. Something. But Canvas uses floats internally, so I think we'll do a float. Line width setter will have set line width double. And this is not a string right here, it's just a value from impl line width. And my phone is lighting up so much today. I don't know what I said or did, but getting a lot of messages. But we're not going to read those right now. So let's see, that looks fine. And then in the C++ object, let's just add those functions here to the, this is the canvas rendering context 2D. And over in the other file, we were editing the canvas context 2D wrapper, which is a JavaScript object corresponding to a C++ 2D context. So we'll need set line width, which takes a float, a flout, line width, and this guy can just return whatever the line width is. Maybe by default it would be 1. I think that seems reasonable. And then we need all of those functions. So begin path, close path, stroke, and move to line to K. Right. So let's do the wrapper stuff, because this is all boilerplate. We just have to like We have to figure out if the object that you're calling this on is a canvas object, and if it is, we have to just forward the call. So it's really straightforward. Like, we just do this, and then we say impl begin path return JS undefined. And close path and stroke are actually going to be identical to this guy. So not terribly interesting functions. And one day we are going to generate this code. One day, but not today. Stroke. I was talking to Nico Zimmerman, who wrote the SVG implementation in WebKit originally, and I mean back when it was KHTML, he made KSVG, and he was saying that this wrapper code here in the Serenity web implementation is so clean and like could be generated so easily, and he's right, and I know, but we're still fact finding, so we're gonna wait a little bit more. Nico, if you're listening, I'm not ready yet. Okay, so these guys are going to be a little bit different because they have arguments to worry about, but they're actually symmetrical. So we can just do the same thing in both. We'll just say x is, or double x is interpreter argument 0 to double. And then we'll do impl move to xy return JS undefined. Yeah. We could do a lot more checking and stuff, but I think this is good enough for now. We don't have to get too much into it. We should just make sure that we actually use the right argument index. Okay, so now we can go and implement the functions in the C++ object. So this is a little bit easier, but also we have to do less boilerplate and more actual stuff. Like now something has to happen when we call these APIs. Move to, and line 2, and then we had stroke. So conceptually, the canvas, the way that it works is that it sort of has a path state. So when you call begin path on a canvas context, it doesn't have like a path object that you can take away from it or like pass around. That was added later to the web platform, but the basic canvas context just has one path. And I'm pretty sure that comes from the original implementation of Canvas, which was part of the macOS dashboard, which was using core graphics, because all of this started on core graphics on Mac. That's the way the CG context API works, that the CG context has a path and then you just add to that path. Whereas most other graphics, 2D graphics APIs that I've ever used at least, they have like a separate path object that you can sort of build up and pass around. And it's a bit funny because one of the things I worked on in WebKit very, very early on when I was very new in that project was like refactoring the WebKit Canvas implementation to use to always use a separate path object, even though that's not how the core graphics platform wanted it to work. Like everyone else wanted it to work that way, so I went and I sort of changed it around so that there was always a separate path object. And in doing that, I made the core graphics implementation a little bit slower because there was more overhead. And then I regretted that many times because I didn't feel right to go back and change that to make it better for core graphics but worse for everyone else. But anyway, that's a whole other thing. So let's see here. Let's do stroke. Okay, so begin path. What we're going to do here, I think, based on what I just said, I would like us to have a separate path object. So I think we will invent something and we'll put it in libgraphics so that it becomes like usable throughout the system, not just in libweb. So we'll have like a path. And let's see. Not really sure how that's going to work. I've never implemented a path itself before. I've used them, but I never implemented one. So I think path.h, that'll be good. And then we say pragma once, namespace, graphics, class path. Libgraphics forward. Let's add the path here. So what is a path really? A path is like, it's a sequence of movements, right, in two-dimensional space in this case. So it's a two-dimensional path. We're not going to concern ourselves with 3 dimensions at the moment, maybe someday in the future, but right now we're focusing on 2D graphics, right? So this is a 2D path. And it will have, I guess, like a vector of segments, maybe. And we'll say that path segment is what metadata do we want? Like a type, I guess. So like an enum class type. Maybe we'll just have move to line 2. And then you have more things here like blah blah blah. But we'll only do move to and line 2 to begin with. Okay. And then I guess we want to have a point position or something like that. Libgraphics point. Maybe we'll call it point. Yeah, something like this. So then the way that this would work is you would build this up using the same style that we already saw. So like move to, float. So this is going to have to be a float point actually. Because integer path, it doesn't really make sense, because if you're using integers, then you're probably not doing like 2D graphics with paths and integer math. Hopefully, maybe. We're gonna use floats. Maybe somebody would use integers. I don't know. So actually, maybe it would be even better here to take a float point directly. So the simple implementation would be m segments append type type. Actually, this should probably be private. So we'll append a move to segment with the point as its point. Alright. Implicit instantiation of the vector template. Well, that is my bad. Okay, there we go. So that's move to, and then we have line 2. And then I don't know if we should make the segment, maybe they shouldn't be private for now because we're going to want to peek into it anyway for the rendering stuff. So maybe we'll have an invalid state here just in case, and we'll make that the default. I don't like having uninitialized things, even if that means I have to add another enum option. Alright, so this is our path. Good enough for starters. And begin path, we'll just replace it with an empty value. Close path, I don't remember what that should do, so we'll just make a no-op for now. I feel like there's some part of it where, like, if you draw like half of a path, then you close path, then it should like go from the last point to the first point in the path and like implicitly make a line there or something. I don't remember exactly. We'll have to look that up. There's some peculiarities about close path I recall, but when it comes to move to, that's really simple. We just make a float point x, y. Graphics float point. Maybe we can even implicitly do that with the bracey braces. And line 2, x and y. Alright. And here comes the money maker, the stroke. So this will have to be done. Grab the painter. Okay, so let's see. Auto painter is this painter. If we can't get a painter, then we don't want to draw anything. So this just means that we're not in the DOM, for example. We're like an orphaned canvas element, so or we're a canvas rendering context whose canvas is not in the DOM, or it's like zero sized or something. So we just swallow this call here. But if we have a place to draw, then I think we should say something like painter stroke path. And maybe with the stroke style, which is a color. Okay, stroke path. So this is something that we don't have yet, but we'll put it into the graphics painter thingy. So void stroke path, const path, and color. Okay. And then, oh, this is the wrong file. Okay, so here, time to actually write some painting code. This has been a while. So let's see, how do we do this? We need the path, like graphics path, so we can see the segments and everything. So I guess we'll just loop through it. For auto segment in path m segments. That's not very elegant. Let's expose that. So vector segment segments. That's a bit better. And then we can just call segments like so. There we go. Okay, and then we'll switch on the segment type. So if it is path segment type invalid, we'll say, golly gee, how did you even get here? And if it is a path segment type move to, we will move the cursor. So I guess we should track that here. We'll track it in, I guess we should track it in a float point. So the painter uses mostly integers for painting. This might be something that we need to rethink and start having a float API. But for now we have integers, so that's what we're working with. We'll call it the cursor. So how does this work? I guess the default thing, by default it will just start as 0, 0, right? But maybe that's okay. Because normally when you start drawing, you would move to somewhere and then start doing lines and stuff. So here we'll just say cursor is segment dot point break. All right, and if we encounter a line 2, then we'll say cursor segment point, but only after we have done a draw line from cursor to the new place, to segment point with the color. Oh, and the thickness as well. So we'll take a thickness parameter here, which will be the line width of the API, stroke path, thickness, we'll say 1, or actually let's not have a default value, and cannot convert that implicitly. What about explicitly? All right, what about very explicitly? Cannot be narrowed to int. Well, all right, fine. Jeez. Point. Okay. You have been coerced into an integer point. Okay. So that's our basic path stroking function. Now we have to go and make sure that we pass the line width. M line width. And yeah, so let's try this, see what we can do with it. We're going to need to also rebuild the graphics. What did we forget here? We need to say type invalid, because it's an enum class. Don't you wish that enum classes would be able to have member functions? Wouldn't that be nice? But they don't. And we'll make do with what we have. Set line width. Oh, we forgot to implement that. But actually, that's not terribly complicated, so I don't know why I wanted to do it out of line. We can just do it here. M line width is line width. Okay, time to give the line drawing functions some exercise, and that did not work. Draw house, undefined is not a function. Alright, fine. So what did we not implement? Begin path. Do we not have stroke rect? Did I hallucinate that? Stroke rect. No, we have stroke rect. Alright. What's missing? I guess we can just go in the system and bring it up, and then we can just edit the file until it works. So let's see, do none of these guys work or what? Still getting a type error. Alright. So what if we also don't call any of those guys? Okay, is this something stupid like query selector can't? Oh, because we don't even have query selector. So that's not going to work. Alright. Yeah, there we are. Okay. We have query selector all, and we have get element by ID. And look at that. it's something. Now we are missing those where's the roof, and also what's up with this is the wall. Oh, wait a minute, this is just the wall and the door. We're missing the whole path. Okay. So let's find out what's going on with that. Also, this guy here should respect the thickness. Canvas stroke rect does not care about thickness. Is there a param for that? No, there's no way to pass thickness to draw rect. Man, the painter class needs so much love. It has like only the bare minimum to draw the UI, but now it's starting to really starting to crack a little bit now that we try to implement something like canvas paths. Okay, so let's not worry about the line width so much for now and leave it at pencil thin stroke rect. Let's worry more about why is the path thing not even happening. So I guess one thing we can do is we can add a way to dump out a path. That would be nice. So let's say that we add a helper like one of these guys. Const log stream and a path, right? Path, and then this will just be stream path to string, and we'll make a stringification thing for it. String to string const. All right. And oh shit, I didn't have a CPP file. We're gonna need a CPP file eventually, I think. Maybe, or maybe we don't. Let's do it here for now then. Segment in segments. Segment type. String builder. This is feeling like such a CPP file logic, so let's move to CPP. I already made space for it here anyway. So let's bring you with us, and you can go here, namespace, graphics, include lit graphics, path, and I need a tasty copyright header, just one. But the right year. All right. There we almost are. Now we just need a little bit of that string builder. Oh, I thought we had two string. Did I? Oh, right. String to string const. Okay, so we'll say something like builder append path, something like that, and builder append turn builder to string. Okay. And then in here we'll say case segment type move to builder append move to bind to invalid. Okay, and then after the segment type, we'll just append or just append one of those guys, and we'll append the segment.point.toString, finally one of those guys. And maybe a space. Okay, I don't know, something like that. That'll be okay. And I actually wanted to log it before we do something with it. Stroke path, path. I think we forgot pragma once somewhere. We forgot inline on this guy. Okay. Oh shit, the query selector thing. Maybe we should add query selector. That's kind of a different patch entirely. Wait, did I already commit the exception thing? Yes, I did. Okay, making a lot of silly mistakes here. Come on now. We just want to see it. Stroke. Okay, so here's our path. Move to 5140. Move to. I am missing some line 2s here, dude. Like, that's probably why we're not seeing anything. Line 2. Line 2. Why are you not doing anything in line 2? Because line 2 calls move to. Oh, look at that. That's a very silly mistake. If you caught that when I made it, good job. And there is our beautiful house. It's not quite as dashing as this one, but that's, you know, stuff like the cap of the pen and the meter limit and all of these 2D graphics things that we don't have yet. But we can at least close the path. So I think that when you close the path, we should implicitly go from the last point to the first point. We just got to figure out how that works. So close path. How is that expressed exactly? Come on, MDN. You can load it. You can load. This website is so bright. You guys need a dark mode. Wait, okay, I should read this. Attempts to add a straight line from the current point to the start of the current subpath. If the shape has already been closed or has only one point, this function does nothing. Subpath, you say. Starts a new path by emptying the list of subpaths. Alright, so how do you start a subpath? Subpath. Move to, oh, so okay, so whenever you move, you're just starting a new subpath. That makes sense that they would think of it that way. Move to starting point of a new subpath. So close path, we should move back to the start of the current subpath. So basically we want to move backwards in the segments list until we find a move to, and then wherever that move to goes to, we draw a line to there. If the shape has already been closed or has only one point, this function does nothing. Okay, so let's see. Close path. So I guess we'll do something like that. and path close, maybe? Yeah, we can implement our path object with the semantics of the canvas path. Why not? Close. So maybe we'll put that one out of line then, since we already started doing a CPP file here. Path close. So what was he saying? That if the shape has been closed, or there's only one point, shape. So I guess the shape is, what is shape in this context? Is shape subpath or the whole path or what? If the shape has been closed already, so does that mean that the current very last point in the path is the same as the very first point of the subpath? I guess that is what it means to already be closed. So let's see. We'll just have to go backwards here. So size ti is segment size -1. As long as we are above 0. So if the auto segment is m segments I, if segment type is segment type move to, if the very last thing is a move to, then I guess we can't close it. I mean, then we are in a new subpath, so we should actually stop there. So when we find a move to, and it's different from the very last point, so if m segments size is less than or equal to 1, we can't do anything, so just return. Otherwise, last point is segments last point. Nice and expressive. If last point is equal to segment point, then it's a no op. Otherwise, segments append segment type line2 to this point, start of the subpath, and then we return. Okay, I feel like that makes sense. Look at him go. That's pretty cool. So I like it. Maybe we should implement stroke rect a little bit differently. We can just use it. We can do it with lines for now in the canvas implementation, because then we'll have it respecting the thickness or the line width. But let's do that in a separate patch. So let's see. First, we will do the code to add the path object, I think, to lit graphics, because it's like standalone and everything. Lit graphics, add graphics path, a basic 2D path with canvas semantics, canvas like semantics. Maybe we should say canvas semantics. Yeah, that's okay. This will be used to implement arbitrary 2D paths, or, well, implement painting of 2D paths as first patch, adds support for line 2, x, line 2 point, and move 2. Line 2, move to, and close. It follows the semantics. It will try to have the same semantics as the HTML canvas element. Okay. Oh, we should probably mention to stroke a path, simply pass it to painter stroke path. Great. Now let's add all the libweb stuff. So libweb, and then we should make a hyperlink to this test page here, so I don't forget. Welcome HTML. Canvas path. Working on the canvas, it really is a lot of fun. Canvas path house. It is a lot of fun. It's very visual, so I like it a lot. It really brings me back to when I first started working on WebKit, when I obsessed about the canvas element back in those times. So it's really great being back at it. Add some basic path drawing functionality to canvas element. This patch adds beginning path, move to, line to, stroke, and close path. As the following methods to canvas rendering context 2D. We also add the line width property. Okay, awesome. So let's make stroke rect use the draw lines instead. So this is currently, it cares about the transform. The transform is going to be, we really need to know how to draw the path with a transform. I think I'm not going to care about that today, but we're going to have to care about it later. But for now, we can just do, let's see, how do we do this with the transform? This would be that we would just draw it float point top left is M transform map. Can we do something like that? We have to pass in a float point. I already forgot how this thing works. So we can just map one point like that, and then we can do top left, top right, bottom left, and bottom right. So that's XY, and then top right is XY with -1. Bottom left is y plus height -1, and bottom right is width -1, y plus height -1. And then we just have to, we just need to draw lines between these guys. So painter, draw a line from top left to top right with the color, what is the color? Stroke style. thickness, line width. This is not going to play super nice with alpha blending, but we don't support that yet anyway, so I get to ignore it. And then, and these are going to be, of course, floats, and we need int points here, but maybe we can... Oh, this is kind of annoying. Top, left, Y. Why do I have to do it this way? It's so gross. I don't want to do it that way. Okay, I'm doing something temporary. To int point. Const float point p. Okay, this is stupid. Why don't I just add something here? To int point. Right? This is what we should be doing. And then we'll just add it here. Float point, point to int point. Return a point with my x and my y. There we go. And then we can just go about our business. Bottom right to the bottom left, and from the bottom left to the top left. Nice. Okay. Lib graphics float point. Let's see, lib graphics add float point to int point. And there we have it. That's pretty cool. Now, obviously, it doesn't look exactly right. Like, you can see that the line here is fatter than it should be, and it doesn't join correctly at the edges, but at the corners rather. But I think that we still managed to make some nice progress here. This is definitely more than we could do when we started. So I'm going to call it a success. Let's say that we'll just say lib web implement canvas rendering context 2D stroke rect with line drawing lines. Drawing rects by stroking rects by drawing individual lines gives us line width support without having to work on the painter draw rect code, without having to extend. Alright, so that was a little cheap, but I think it's okay. So this is all pretty cool. Now, right, we're still invalidating based on that. That's okay. So this is all pretty nice, and I think probably going to be done here for today. But I'm very happy with the outcome. So if you made it this far, then I thank you for watching, for hanging out. I hope you saw something interesting here while we made the browser draw this beautiful house. And a special shout out to everybody who has joined on Patreon and GitHub sponsors and has been sending in PayPals recently. Suddenly there was a little, I don't know what to call it, like all these people coming at the same time. So that's really nice. So welcome everybody, and thank you for the support. it's really, really nice to have all the support. So thank you, and I'll see you next time. Bye.